Hi everybody, my name is Nathan. This is Remy, Mateo, and Adam. We are seniors from Lincoln High School in Portland, Oregon, and our presentation is titled Thorium, Powering Peace Through Safe and Sustainable Energy.
All right, quick show of hands, who has heard of thorium?
How do I switch it?
All right, it seems we have a few experts among us today. So, as we know, the global demand for clean and reliable energy is growing every year, and the problems with current sources of this energy, like uranium and fossil fuels, are becoming harder and harder to ignore. Fossil fuels drive climate change, and uranium-based nuclear power, while powerful and great at generating a lot of energy, comes with a bunch of challenges like serious waste risks and general safety risks, while also being not very sustainable. And so that's where thorium comes in. A lesser known but incredibly promising alternative, thorium has the potential to generate large amounts of energy with fewer risks and much less environmental impact. It's also more abundant in the Earth's crust, meaning it could support long-term sustainable energy production. In this presentation, we'll look at two main ideas: the current issues with common isotopes like uranium-235 and 238, and the key benefits of thorium, including its safety, efficiency, and security advantages. Thank you.
Nuclear energy, how it works. Nuclear energy is produced through a process called nuclear fission. That's when atoms are split apart, specifically the nuclei of the atom, releasing a huge amount of kinetic energy in the form of heat. In most nuclear power plants, uranium like 235, 238, or 233, or plutonium-238 atoms are bombarded with neutrons, causing them to split and release even more neutrons and heat, which leads to a chain reaction until there's no more fissile material. And then the heat is used to boil water, creating steam that's captured by a steam spins like a turbine, which is connected to a generator, which is how we produce electricity. And then afterwards, the steam is cooled back into the water cycle and reused in the system, making a relatively efficient cycle. One big advantage of nuclear energy is that it doesn't rely on burning any fossil fuels. So it produces no greenhouse gases during the operation. Many do argue that mining for the fissile material like uranium-235 does require using fossil fuels, but that's why we're here presenting thorium, which is way more abundant. And then, however, another downside is it creates radioactive waste, which has to be stored underground. The U.S. has a really big storage center underground in Nevada, and they're running out of space, and they're not going to know what to do anymore. And a lot of people rely on nuclear energy. So, yeah.
Okay, I'll be talking a bit about the downsides to current nuclear energy. So while nuclear energy is powerful, it also comes with many major safety risks and environmental challenges as well. Traditional reactors operate at extremely high temperatures and pressures, so that just means that there's always the potential for accidents or meltdowns. Even if they're rare, it's just not worth the risk. And they can have really devastating consequences. The mining of uranium and plutonium also creates serious environmental damage. So that means it destroys ecosystems, it contaminates water sources, and it also exposes surrounding areas to radioactive materials. On top of that, the waste produced by these elements stays toxic and hazardous for thousands of years, which makes safe, long-term storage a huge challenge. Another major concern is security. Uranium and plutonium can both be used to make nuclear weapons, which, as we talked about, increases global security risks and concerns about proliferation. And finally, nuclear power plants are expensive and also time-consuming to build and maintain, which makes it harder to expand and modernize them quickly.
Now I'm going to talk about some of the benefits of nuclear energy. One of the biggest strengths of nuclear energy is its reliability. Unlike solar or wind, it can operate 24/7, no matter the weather or time of day. Nuclear power also has a much higher energy density than fossil fuels, meaning a small amount of nuclear fuel can produce an enormous amount of energy. In fact, according to the U.S. Department of Energy, nuclear power is responsible for almost half of the country's emission-free electricity. It produces very low carbon emissions and almost no greenhouse gases, making it a key part of the push towards cleaner energy. Nuclear energy also supports energy security. By reducing our dependence on fossil fuels, it helps promote greater self-sufficiency and stability in the energy supply, which is especially important as global demands continue to rise.
Now, let's talk about the benefits of thorium. So, thorium is a naturally occurring element that's actually found in most soil and rocks. It's about 3 or 4 times more abundant than uranium, which means it's much easier to source and more sustainable in the long run. Unlike uranium-233, which is fissile and can release energy through the same fission process used in nuclear reactors. This makes thorium a cleaner and more sustainable alternative, especially since it eliminates the need for uranium mining, which is harmful to the environment and dangerous for mine workers as it releases harmful, cancer-causing radon gas. Also, economically, that's quite expensive because a whole bunch of infrastructure has to be put in to mitigate the proliferation of radon gas. Yeah. And thorium also has major safety advantages. It's not easily meltable and it naturally slows down reactions at high temperatures, which reduces the risk of any sort of meltdown. Plus, it's extremely difficult to use thorium in nuclear weapons, which helps support global nuclear peace and security. Even when it comes to waste, thorium performs better. Thorium just performs better. And it has a much smaller half-life than uranium-235's massive half-life, which is, how long was it? 700 million years. So that just means the nuclear waste is far less long-lasting and a lot easier to contain. Yeah, thank you.
Next, I'll talk about the limitations of thorium. Even though thorium has a lot of potential, there's still some really big challenges that come with using it. For one, thorium itself isn't directly fissile. It has to be converted into uranium-233. That process is pretty complex. Uranium or plutonium has to be bombarded with a neutron, and usually that's done with a small amount of fissile material from uranium-235, which we would still have to get, but it would be a lot less from using the whole having all fissile material being from for the nuclear fission, and then it turns it gains a neutron, and then it loses an electron and it turns into proterium-232, and then it takes another 27 days of beta decay and it turns into uranium-233, and then so thorium basically makes the uranium-233. And then another issue is that uranium-233, which is it turns much more radioactive, means that the new way storage methods will need to be developed to handle it safely. And then on top of that, there are economic barriers developing thorium reactors, which is expensive, and right now uranium-based systems are much cheaper and more established. And overall, thorium, it does show great promise, but not yet proven on a large commercial scale. Continued research, funding, innovation, and global collaboration will be essential before thorium can truly become a mainstream energy source.
So just to conclude, I'll be summarizing some of the main points. So as a whole, thorium gives us a rare opportunity to completely change the future of nuclear energy because it offers such high efficiency, it produces less waste, and it also provides far greater safety than traditional uranium-based systems. So from a sustainability standpoint, thorium is incredibly abundant and means that there's enough to meet global energy demands for generations to come. And in terms of security, it poses a much lower risk of weaponization and also allows for more stable, safer reactor designs. Environmentally, thorium stands out too. It creates minimal long-term waste and operates much more cleanly, which also helps with our goals of green and responsible energy production. So in the end, I guess investing in thorium, it's not only about improving technology, but also making a safe and sustainable energy future for the planet.
All right, now we're going to do a little quiz. We have 4 multiple choice questions, and we're going to call on the first person to raise their hand. And we have a little prize for if you answer it right in the form of some gear from our school. All right, the first question. What makes thorium a safer option than uranium in nuclear reactors? A, it's not easily meltable and naturally slows down reactions at high temperatures. B, it glows in the dark and repels radiation. C, it produces ice instead of heat during fission. Or D, it doubles as a clean drinking water source.
I saw red in the back, but you over there in the red? Yeah. That is right.
That's correct.
After this. Yeah, after you can come on over and grab it.
Yeah, once the quiz is over, feel free to come on over to the Lincoln table for some gear. All right, next question. How much more abundant is thorium than uranium in the Earth's crust? A, the same amount. B, 100 times more abundant. C, 3 to 4 times more abundant. Or D, none. It's only found on Mars.
Right here in the front.
What's that?
3 to 4 times more abundant? That is right. That is correct.
Wait, yeah, someone's got to watch and don't raise your hand maybe till we read all the questions or all the prompts, answers. Maybe I don't know. That stand up if you want it the most. Yeah, wait, yeah, stand up if you want it the most. Okay. What is a major barrier to using thorium for energy? A, it disappears when exposed to sunlight. B, current reactors aren't suitable for thorium use. C, it's too softly handled to handle safely. And D, it turns into chocolate at high temperatures. Oh my gosh. Oh my gosh.
Oh my gosh.
Yeah, you over there. That is correct.
Oh, wait. Okay, final question. Did I? I'll say it anyway. This is the last question, right?
Yeah.
Okay. Sorry. Why does thorium support global security compared to uranium and plutonium? Is it A, it's difficult to use in nuclear weapons? B, it can be used to power lasers from space? C, it automatically detects spies? Or D, it sings lullabies to calm reactors down? Holy shit, dude.
A is correct.
Let's do Q&A.
We should all say thank you in unison.
Yeah. Oh,
Thank you.
thank you. What should we do Q&A?
No, we're not doing Q&A.
No Q&A?